We've got a bunch of them, and we're going to give them a shot. First of all, I want you to turn to basically the last page. Looks like this, second to last page. You do what you want. I would recommend that you tear off these last 2 pages right now and have them in front of you while you work. But if you want to keep them stapled on the back, then fine. But these are the 2 pages that you get to use on the test, okay? They have all the formulas that you'll need. And you need to be able to know where to locate the formulas, and you need to know how to handle them, okay? If you flip that one over, you got this page. And you've seen this before, haven't you? In fact, I think I've maybe even given you all 3 of these pages in the past, but now I'm giving them to you and telling you that this is kind of what you're given on the test. So I figured some of you probably lost it. And right now we're going to focus on 1, 2, 3, and 4. We want to simplify trigonometric expressions. Again, this is useful, especially in calculus. So, tangent is sine over cosine. Everybody know that? Cosecant is 1 over sine. Secant is 1 over cosine, and cotangent is cosine over sine. Huh, what do you notice? All 6 can be written in terms of sine and cosine. Yeah. I mean, every single one of the trigonometric functions can be written in terms of sine and cosine. So that will allow us to rewrite them and see if certain things cancel off. For example, let's look at the first problem. It says simplify sine of theta times secant of theta. What I do is I write them in terms of sine and cosine. Sine is already in terms of sine and cosine, isn't it? So I just write sine of theta over 1 times secant of theta. Secant is not in terms of sine and cosine yet, so I write it as 1 over cosine of theta. Nothing cancels, does it? So I end up with sine of theta over cosine of theta. What is sine over cosine? Tangent. Two can be written as 2 over 1. Same thing as sine. Sine can be written as sine over 1. Secant, I want to write it in terms of sine and cosine. So if you look at it, secant says that it is 1 over cosine. Right. I have no way to explain this other than to do the problem incorrectly. Let me show you. Sine of theta times secant of theta. If you would so choose to write this as 1 over cosecant of theta times 1 over cosine, you end up with just confusion. We don't see how that at all turns out to be tangent. And the reason why is this. This was written in terms of sine. You chose to write it in something that's not sine or cosine. You don't want to do that. You want to have sine and cosines everywhere. And as you can see how we originally did the problem, we left sine alone. We changed secant so it would look like a sine or a cosine. So that's our objective. So B, sine, again, is written as sine over 1. But cotangent, how do I rewrite cotangent? What's cotangent? Cosine of theta over sine of theta times sine of theta over 1. Now that they're written in terms that are similar to one another, Quinn, what do you see? Sines cancel, you're left with cosine of theta. I can change secant and cosecant. Secant is 1 over cosine. Cosecant is 1 over sine. Does anything cancel? Nothing cancels. Is there anything that says cosine times sine is something special? No. So the fact of the matter is that this doesn't simplify at all. That is its most simple form. Its simplest form, excuse me. Connor, question. Yes, excellent point. So here's just the short of it. This right here, um, I do not have this in front of my calculus students. All this they should memorize. Okay? I give this to you on the test, but the more you know these identities, the faster off you're going to be. I would encourage you to get to know this whole page very, very well. Because when we do this during calculus, we don't ever go back and look at the page. We try to pull it from memory and even generate the formulas on our own. And after this unit, you'll feel better with that. So right now, you either need to do one of two things. Number one, start to memorize it, or number two, become very familiar with its location and go back to it quite often. So that would be it. Now, just to be clear, are any of these four new to us? No. We've used these over the past 2 months, haven't we? In fact, you've seen this before, haven't you? Sine squared plus cosine squared is 1. We used that on your 5-1-6-1 test. In fact, we even used that one and that one. This is the portion over here to the right that is new to us right now. And I'll show you what to do with that in a little bit. So let's continue to practice. As we practice more of these, you'll get used to going back to your spot. Okay. Let's look at D. What is cotangent in terms of sine and cosine? Cosine of theta over sine of theta. Yes, cotangent is also 1 over tangent, but that doesn't help you. We need it written in terms of sine and cosine. That's helpful. Times, what is secant? 1 over cosine. What happens? The cosines cancel. You're left with 1 over sine of theta. What is 1 over sine? Cosecant. Very nice problem. You try E and F on your own. Give it a shot. Go. Okay, I'll write both these down. Sine of theta over cosine of theta times 1 over sine of theta. And you notice that the signs cancel. You're left with 1 over cosine. What is 1 over cosine? Secant. Secant times cosecant times cotangent. This one's trickier. 1 over cosine times 1 over sine times cosine over sine. Now, on the test, I give you a point just for writing that. Just changing it from sine to cosine. So, and I give you these formulas, don't I? So we all can do that. Now, you got to see that it cancels. And a lot of people see that it cancels as well. Here's what they do. When they don't know what to do with the sine squared on the bottom, they just start crossing out the signs and they say it's equal to 1. That's not correct. It's 1 over sine squared. And if you notice, 1 over sine is cosecant. So 1 over sine squared is cosecant squared. Okay, in these situations, it's written in a fraction. And I'm just going to write as a complex fraction and simplify as we practiced before. Tangent is sine of theta over cosine of theta. Secant is 1 over cosine. So I'm going to multiply by the reciprocal. As I multiply by the reciprocal, what happens? Cosines cancel. I'm left with sine of theta. That's pretty good, huh? What would you want to write? No. No. It is a lot of work to write that kind of symbol right there. Fran, they say that sarcasm is not good in teaching. Do you think I'm being too sarcastic with Miss Savacool? All right. Did I hurt your feelings, Sarah? Oh my gosh. Wow. I just called her Sarah again. Unbelievable. Wow. You're so much smarter than Sarah. Please don't take that. Not tell her to watch the video. Okay. So we got 1 over sine of theta divided by, what's cotangent? Cosine of theta over sine of theta. And you remember that when you divide, you multiply by the reciprocal times sine of theta over cosine of theta. What happens? Sines cancel. 1 over cosine is secant. See, you feel like you're getting better at this, don't you? Let's try this. Let's try this one. You guys can do the last 2 on your own. Sine of theta over 1 times what's secant? 1 over cosine times tangent is sine over cosine. So I'm going to multiply by the reciprocal. So times cosine over sine. What do you notice? Isn't that nice? In probability theory and trigonometry, you got a really good chance if you don't know the answer, just kind of write a 1 and put a box around it. So, you are not given credit just for getting the correct answer in this unit, but as always, your work must support your answer. Okay? So you have to show your work in order to get full credit on the test. You try J and K on your own. See what you can get. You guys are smart. Tangent is sine of theta over cosine of theta. Divided by, I don't change cosine. I just write cosine of theta over 1. And cosecant is 1 over sine of theta. So you have sine of theta over cosine of theta over cosine of theta over sine of theta. So I'm going to multiply by the, so you get sine of theta over cosine of theta. Do they cancel? No. You get a sine squared over cosine squared. And sine squared over cosine squared is tangent squared. There's your answer. What? Why are you laughing? Anna, why are you laughing? Connor doesn't ever disrupt class, okay? He's a model student. He's going to focus like he's supposed to and do a good job. All right, sine squared times cosine over sine times 1 over sine. This is a nice problem, isn't it? You got 2 sines on the bottom, you got 2 sines up top, so they both cancel, and you're left with just cosine of theta. Bada bing, bada bam, bada booski. Done. So, on a level of 5, okay, these are type 1 problems, okay? These are type 1. So you ready to try some harder ones? Okay, here's the deal. You've also learned 1 skill so far. That's converting from sine to cosine. There's a lot more methods to try. Let's try another one. Tomorrow? Why put off tomorrow what we could do today? What if we run out of math to do? Oh, goodness. Savor these moments. Wow, you're a lot of talk. All right. Sam, don't you think you should try some triple jump? Yeah, you're gonna today. Today we're triple jumping. Okay. All right. Look at L. Okay. It says 1 minus cosine squared times cosecant. Some people take this problem, and what they will do is they will multiply through by cosecant. They'll rewrite it as 1 over sine. Bad idea. Bad idea. Anybody see? You don't see. Okay, so first rule is change the sign and cosine. Second rule is look for a substitution. You see it? That's it. Oh, awesome. Great idea. Because this is the difference of two squares, correct? Yes. Excellent idea. It won't work, but great idea. Great idea. Let's clap for she gave yeah. Honest effort. Exactly. So thank you for speaking up. Great idea. Doesn't work. Gabe, what? Yes. So your second piece that you want to look at is substitution. Okay. Now I'm going to direct your attention to these bottom three. Okay. Look at what we have. Sine squared plus cosine squared is equal to 1. If that equation is true, there's a lot of different ways we can write that equation. For example, this is super important. Can you wrap your brain around this? If sine squared plus cosine squared is equal to 1, does it also make sense that cosine squared is 1 minus sine squared? Does it also make sense that sine squared is 1 minus cosine squared? So, yeah, this is the main formula, but from those we get these two others. Then, as Anna said, they do factor. You have the difference of two squares. We're going to get to that piece tomorrow because we don't really use it at all right now. But what Anna sees, or I'm sorry, what Gabe sees is that since you have the 1 minus cosine squared, I could substitute something else in. That. So let's do it. See that substitution? Instead of writing 1 minus cosine squared, I write sine squared. That was nice and easy, wasn't it? Now I can rewrite it using sine and cosine just like we practiced. Sine squared of theta over 1 times 1 over sine of theta. What happens? One of the signs cancel. I get sine of theta. Done and done. Look at M. If you can substitute something in right away, then do it. Can you substitute something in for secant squared minus 1? So cosine squared of theta times tangent squared of theta. Can I rewrite tangent squared? Sine squared over cosine squared. What happens? Cosine squareds cancel. I get sine squared of theta. Isn't that nice? Connor, ask your question again. Okay. So this is, no, don't write this down. Connor asks a question, okay? And I'll do my best to explain it. We don't really know how to do that problem in calculus. But we've already said, we've already said that the tangent of x divided by secant of x gives us sine of x. Now this is easy. I know how to do this. So my point to Connor is this, is that You say, what is it? It's a way to rewrite it in another way that is simplified that I can actually do something with. Okay? So I can use that in calculus. I can't really make use of that. And so that's what you're trying to do. That's where this will be most useful moving forward. All right, you try n on your own. Try n on your own. Go. Okay, boys and girls, this is one of my favorite problems to consider putting on the test because it requires three really big steps. Number one, a lot of people convert secant squared to 1 over cosine squared. Bad idea, okay? What you want to do instead is substitute tangent squared for secant squared minus 1. That's the correct step. After that, if you notice, you have to rewrite it. Sine squared over cosine squared over sine squared over 1. When you multiply by the reciprocal, what happens to the sine squareds? They cancel. Is the cosine left in the numerator or the denominator? It's in the denominator. You got 1 over cosine squared. And we know that 1 over cosine is secant, so we get secant squared. Love that type of problem. It requires multiple levels of thinking. You know, like I said, a lot of people approach it the inappropriate way right away. As I told you, I will put all the problems that you see on the test will be problems you've seen before in class. Okay, because we just do that many. Okay, we've only got 3 more problems to get through. Then you have your assignment. So let's look at this one. Problem O. This is a different method. So we've talked about substituting something in. We've also talked about rewriting in terms of sine and cosine. I don't want to do that here. If you rewrote tangent squared in terms of sine and cosine, you would have sine squared on the top times another sine squared, wouldn't you? What's sine squared times sine squared? Sine to the 4th. That doesn't help us at all. So, anybody see the trick? So if you write 2 minus 2x in algebra, can you just cancel off the 2's? Oh. Now, this is a situation where you've got order of operations. You can't do that. But Gabe is correct. You are going to factor out. Watch what we do. Now, a lot of people miss this, and I don't see why. All I know is it happens, and so I'm going to show you. I'm going to show you what this would look like if we were doing algebra. X squared minus x squared times y squared, okay? So instead of a tangent squared, I wrote x squared, all right? If you factor out an x squared, what are you left with? 1 minus y squared, correct? So what I'm going to do is I'm going to factor out a tangent squared. And when I factor out a tangent squared, I'm left with 1 minus sine squared. Oh, look at that. All of a sudden, I see something that I might be able to substitute now. What is 1 minus sine squared? So now I have tangent squared times cosine squared. 1 minus sine squared is cosine squared. Hey, I can rewrite tangent in terms of sine and cosine now, because I can see that I'll get a cosine squared in the denominator. And that's going to be helpful because I'm going to get some canceling here. What cancels? Cosine squareds, I get sine squared of theta. Isn't that nice? Okay. No, it's totally illegal. Okay, so I know that some people you want to do this. Okay, you want to do this. So for example, if I wrote tangent squared of theta minus tangent squared of theta times cosine squared of theta, you would say, oh, subtract the tangent to get cosine squared. No, it's just by chance that it works out like that here. Trust me, That is not. There's nothing mathematically sound about going from here to here. Nothing. You just got lucky that it ended up being sine squared. Okay? Keep an eye on you, Hendrickson. Okay. P. What can I factor out? Sine squared times what's left? Hey, that looks pretty good. Secant squared minus 1 is tangent squared. I'll try to rewrite that in terms of sine and cosine to see if something else cancels. Anything going to cancel? No. So I just stop here. That would be the most simplified result. You can see how I get a sine to the fourth over cosine squared. This is as good as I can do. You try Q on your own. Go. You guys aren't about that. So, you take out the cosine squared, and you get 1 plus tangent squared. And you can see from your sheet, it tells you right away, we derived this a long time ago. It tells us that 1 plus tangent squared is secant squared. Okay? So, go back to my problem, and I will write this as cosine squared times secant. What's the relationship between cosine and secant? They are reciprocals, aren't they? When you take two reciprocals and multiply them together, what do you get? You get 1. Okay. Here's your assignment. I got one more easy problem to show you. Bad idea to put these assignments off at all. I mean, you should do them the night of. And if you miss school, trust me, you miss something new that you will not be able to just figure out on your own. Somebody told me that they've never watched one of my videos. That's fine. Good chance you might have to this unit. Okay. So 7.1, page 540, numbers 1 through 6, 8 through 10, 12, and 13. And I want to quick show you one last example. What do you notice is different about this problem compared to the ones we did? There's negative angles. And if you look at the other sheet that we were using, it has these negative angles. They're called even and odd identities. And the deal is in trigonometry, we never leave a negative angle. We don't. It says that if you have a sine of a negative angle, you simply move the negative out front. If you have tangent of a negative angle, you move the negative. But if you have cosine of a negative angle, you just make it positive. Nothing happens, okay? So these even and odd identities we can use as well. So I'm going to do that quick example right here. Tangent of negative x would be a negative tangent of x. Sine of a negative x, I move the negative out front, so it would be plus sine of x. And cosine of negative x, the negative just goes away. That's how you would write the answer. If you have questions why it just goes away, I can show you that, but we can prove these using some different formulas and whatnot. But it has to do with even and odd functions, which is something we covered earlier. Tangent and sine change value. Cosine, you just get rid of the negative. Okay? Same like secant. Secant's the reciprocal of cosine, it would be the same thing. There's your assignment. You guys have 50 seconds. Okay? There will not be a lot of work days during this unit. Okay? Trust me. So make sure you stay on top of your homework at home.